everyone. So this is something we're definitely going to learn after spring break. Or sorry, after the ACT. Whew, spring break already happened. But I wanted you to be aware if you are someone who feels like you've already got all this other ACT stuff and you want to learn something new. That's what we're going to do right now. So I'm going to work through these problems, try to catch along as we go. So it says for all x is greater than 0, right? That's important because if x is 0 here, 2 divided by 0 is going to explode the world. It doesn't work. And so that's why they tell us that first part. Not super necessary for our problem. So it says 2 over x minus 3 over 5. So as you know with fractions, we have to have a common denominator. And what I see here is that there's an x and a 5. Just like if there was a 3 and a 5, we would multiply them. We can just take this and multiply that by 5, and take this and multiply that by x. That's going to give us 5x on the bottom. But don't forget that what you do to the bottom, you have to do to the top. And so that would mean that we would have 2 times 5, which is 10 over 5x, minus 3 times x, which is 3x over 5x. I can see now that they have the common denominator of 5x, so that can go on the bottom, and I have 10 minus 3x. That's going to give me correct answer A. So we're just combining them by using like terms on the bottom. For number 2, it says in the equation y equals this, x is a positive number. So x is like 1 or 2 or 3 or 4. As x gets larger without bound, so that means as x gets bigger and bigger and bigger and bigger for the rest of its life, the value of y gets closer and closer and closer to something. So we have a couple options. We could just try numbers. So if I put a 1 there, this is like 3 over 4. If I put a 2 there, this is like 3 over 5. If I put a 100 there, it's like 3 over 103, right? Close. If I put 1,000 there, I get 3 over 1,003, right? So what's happening to y, if I look at this, this is like 0.75, this is 0.6, this is, I don't know, something really close to 0.03, this is something 0.003. It's getting smaller and smaller and smaller. It's getting closer and closer to 0, right? And it's not going to stay the same. It's not going to get larger and larger. It's not getting closer to 1, not getting closer to 3. If you wanted to graph this on your calculator, you would also see something that looks like kind of like this. And you would see that it's getting closer and closer and closer to 0. And no matter what, it's always going to get closer. So we see that it's A. These ones are some of my favorite problems. So what we're going to do here, remember that this is like a bound problem. We don't really have to worry about this. We can come back to it if we need to later on. But what we're going to do is we're going to factor out the things that we know. So in this section, what's common is an x. And what's left over is 3 minus x. In the bottom here, we can see that this is a trinomial, so it's going to split into 2 pieces. This is x and x. This is like your x factor, so -6 on top. Multiply to get -6, add to get -1. So I know 3 and 2 do is -3. So -3 times 2 is -6, plus would be -1. So I have x minus 3 and x plus 2. All right, so I can only cross things out if they're the same on top and on bottom. I see that 3 minus x and x minus 3 are very similar, but they're not exactly the same. So what I can do in order to change them into something that is the same is I would say right now, this is -x plus 3. I just took this part, moved it right here. If I take a negative out, let me backtrack this just a little bit. So I have x, and then I would say this is -x plus 3. All I did was rearrange, right? So now instead of the red line, we have the blue one as our numerator. If I factor out a negative from this here. I'm going to take a -1 to the outside. That's going to leave me with a positive here and a negative there. So what I'm going to be left with is -1x times x minus 3 over x minus 3 and x plus 2. The reason that that helps me is because now I can see that x minus 3 and x minus 3 are the same. They can cancel out, and I get -1x over x plus 2. I'm going to look for a similar one. This one's not negative. That one's not negative. This one's not that. I see, okay, this one could work. I have a negative there. I have 1x on top. I have x plus 2. So I see that that would be my correct answer there. Right? If this was tricky, I can show it to you in a different way. So remember I was at x and 3 minus x over x minus 3, x plus 2. All right. I could say that I'm still going to have to factor out that -1. So from here, I'm going to take out a -1. That x is still the same from before. But now, since I factored out the -1, I'm going to have -3 plus x. Right. What's on the bottom has not changed at all. So I still have x minus 3 and x plus 2. Right. I can see that these can be rearranged. So that would be x minus 3 on top there with a -1 x and an x minus 3 x plus 2. Then we see again that cancels, so we get our same thing that we got here. It's okay if it's complicated. It's definitely something that we'll work on, but if you're ready for it, it's awesome. Go ahead and look at 4. It says, what's the real values of x that make this true? So let's see. I know that I can, looking at the top, I can take an x out, and that would be m plus n. Looking at the bottom, I can take a 2 out, so that would be, there'd be m plus n left over. Remember, I'm undistributing, so I can take that 2 out from both of those. That cancels here and lets me see that x over 2 is less than 0. From there, I can multiply times 2 on both sides. X is less than 0. D. That's my correct answer. So it can be pretty magical when we start to factor things out. It says x is any number other than 2 and 3, then this happens. So we can see here, these automatically cancel because they're exactly the same. And then we're going to do that same nifty trick that we learned over in number 3 with the negative. So this here can be factored into -1 over x minus 2. So they flip sides. So the negative x becomes positive. The positive 2 becomes -2. So then if I'm going to rewrite this real fast, on top is left x minus 2. On bottom, -1 times x minus 2. That nifty thing is going to get rid of this and this. I don't have anything left on the top, so it's just 1. 1 over -1 is -1. B. It can be really fun once you get the hang of it, I promise. One last one. This one, remember that we have this would be x plus 6, x minus 6. Remember that's the difference of squares on top there. And then I see this part here. There are 2 of these things. So I have x minus 6 and x minus 6, like that. I see an x minus 6 on top and 1 on bottom, and I'm left with these. And that is my answer right here. Sweet, y'all. Those are some rational expressions. If you want to work on some more, I can point you in that direction. But you're just going to Google, or you can go on Albert and search rational expressions, and you'll find some really awesome problems. Thanks, guys.